Thank you very much. Good evening, everyone. My name is George Gourgouletis. I'm a chemist, and I did the Master of Engineering in National Technical University of Athens. So yes, I studied chemist, but environment is is real my passion the last 10-12 years so far. So I created the Science Me. Science Me is a digital platform for basically communication of science, of technology, AI, and more. And one of the recent focus of the Science Me is the PFAS in water and generally in the environment, because what you may know as well is that PFAS are everywhere. And because today all the members here belong to the climate change community, or the climate change defense, as I'm always saying, is that all of these delivers. All of this that we are discussing nowadays, it's not news. It's not something that happened only yesterday. So I have this letter, which is on the internet the last, I think, 1 year. It's on 1977, and I think the president was Jimmy Carter. A secret memo landed on this desk of the Oval Office to the U.S. president that a committee of the U.S. administration informed him actually that the climate will change because of the CO2 levels, because of the fossil fuels, and because of the heavy industry, acceleration of the technology. So from that time, I think you are all aware that we did almost nothing. I mean, I'm not the person that I have to zero all the actions, but the basic, all the governments or all the administrations, actually they did the bare minimum, allow me to say, okay, from that point. So from 1977, we have, let's say, one of the first formal letters that the scientists informed the US administration of what is coming. But now we are, just a moment, we are on the PFAS side. PFAS, as I told already to Dr. Stefanakis, you may have seen that in the literature that PFAS is describing, among other compounds, like forever chemicals or forever pollutants. I really don't like, personally, this jargon of forever chemicals, because it's somehow pessimistic terminology. But they are here for the eternity. So let's look at the structure, okay, and why they are so important. So PFAS are in two modes, let's say short chain of carbon or long chain carbon. So that means that we have PFAS from 3-4 carbon atoms to 8 or 12. But the basic issue here is the connection between carbon and fluorine, which is very strong and really impossible to decompose or to break this bond into the nature by nature forces or by the by natural degradation. It's almost impossible to break this bond. And there are also some other atoms as well. I mean, like oxygen, like hydrogen, or like sulfur, that they make even more complicated those compounds. So, because of the structure and because of the carbon fluorine, PFAS are very stable in the nature. So they remain for hundreds of years in many ways. And this stability is something that that circulate into the nature in a different ways, in different paths, and even nowadays we can determine PFAS on our blood as well. There are statistics in US and Europe that we expose ourselves in PFAS compounds. So, more or less, the PFAS, they have two different structures because of the sulfur atom or the carbon atom as well, and we have short chain for 7 carbons or long chain 8 to 12 carbons. And again, for 5 or 6, 12. Apologize for the chemical stuff here, but it's something that we have to keep in mind for the next slides as well. So, again, apologize for the Greek. I was not prepared for English, but okay. PFAS nowadays, even the PFAS regulation in drinking water determined as partially PFAS or total PFAS for, I think, more or less 20 compounds. Actually, in the real life, there are 10,000 synthetic PFAS compounds with different physicochemical properties. And for many of them, we are aware of that they have a really dangerous effect and impact to the human body. But for the remainder of them, we have nothing at this moment. All of them, they actually manufactured at the beginning of of the industry era. So that means 1930, and actually they introduced to the human market, I mean human consumption products at more or less 1950, 1960, and later on 1970. 1970 and 1980, those are the dates, or the years that we've seen increase of the PFAS exposure, because we've seen many plastic products in the market. So from the year of 1970, we know very well from the U.S. agencies that from the U.S. administration that they found PFAS in blood of workers, of laborers in many industrial areas. And later on 1990, later on 2000s, I mean, we have a lot of indicators that PFAS are everywhere in human body. So those are the bad news, okay? I mean, we have the PFAS, which is long chain compounds or short chain compounds, difficult to break them. And the reason of what is going on right now is that we've been late to monitoring them or to know them. So, and the problem here is that we investigated firstly PFOS or PFA, I mean, as two big groups, because at that time the technology, I mean, late 1980 or 1990, we didn't have the instruments, let's say, to look at the trace levels of PFAS in water. Later on, we have regulation of drinking water that covering many of them. I have to say that UK and US administration were the first of them, the first of the administrations that they were running PFAS measurements. And later on, we have some of fluoroteluromers, ethers, and perfluoropolyethers that we are worried about. Here, allow me to say that the target is to look after all the PFAS. Right now we have indications that there are more than 5,000 or 6,000 PFAS compounds in nature. And as I told earlier to Dr. Stefanakis, is that European Union or the European regulation many times describe PFAS as a very general terminology, and they include also microplastics or natural micropollutants or whatever, which is not very correct. It's something that they try to consolidate in discussions. And a comment here is that I think that European Union, I think also for the US administration, will follow in the next decade or the next 2 decades a more general consolidated regulation for all of this. So, I will skip this because in Greek, I think this slide is perfect. Where we can find them, almost everywhere, right? So, if you see, we can find it in firefighting foams, in microwave bags, clothes, paint, cosmetics, pesticides. I mean, it's something that actually you you cannot run from it. I mean, it's really difficult. Allow me to say also that the major players, let's say in PFAS, are firefighting foams. Okay, so they have some strong carbon fluorine compounds, you know, to seize the fire. And the problem here is that, and since we are in the climate change companion here, imagine that you are in the area of a wildfire happening, so you are trying to seize the fire in a very effective way. And at that time you are using a very effective firefighting foam, but in this area you are providing the highest effective PFAS in soil, in the air, and in the water. So it's a lose-lose game. So and this is a problem that, and we've seen that in the recent wildfires in the Los Angeles and California. We've seen that in many measurements on the recent wildfires in Evia Island here in Greece, and here in Athens, of course, because of the firefighting foam, right? One other major player are pesticides and cosmetics, and here is also a key thing for European Union that they're trying to ban some of the PFAS and those compounds like pesticides in all European countries as well. So, and what is let's say the circulation of that? I mean, imagine that you are producing something like a foam, like a plastic product, like a cloth, but later on, even if you are wearing it, or even if you are eating from it, or in a very indirect way because of the pesticides or because of the agricultural consumption or whatever, you may have PFAS, and this is the reason, this map, let's say this road map, this is the reason that we may have PFAS on our blood. And this cycle actually indicates the problem. But as long as I don't want to hear me as a very pessimistic chemist, working in a lab rat mode, I have to say that, and by taking the example of pants, because I don't know, I think all of you have Instagram. So there are Instagram accounts out now that they're taking pants from the market and they indicate that these are PFAS inside, that you may have cancer or you may die or whatever. So it's not that simple, right? So PFAS are very strong, okay? They are one of the potential threats of cancer, sure, but this happens because of years consumption, not by using it day after day or whatever, okay? It's like, I mean, as a chemist, I always like the example of Coca-Cola, right? So, okay, if you're drinking 52 cola drinks in a day, you may have blood sugar issue. But 52 colas, yes, I mean, it's really crazy. It's something like that also for PFAS, right? But The problem is that if we amplify the focus on 10 or 20 or 30 years, we may see the real bad impact of the PFAS. Okay? The problem is that all of those substances are everywhere in many, many different ways, so they interact by themselves also with different paths. And this is something that the recent studies, the recent 10, 15 years, because of the new technology from the chemical analysis arise, is that we are trying to indicate those paths in order to understand other PFAS compounds. I will go back to my slide here. I mean, those are 4, 9, 11, almost 20. So there are everywhere right now 5,000 PFAS compounds, and they are very toxic, but there are more than 10,000 or 20,000 PFAS that somehow toxic. So that means if you change this structure in many, many ways, you may have less or more toxic substance. I will go away from the chemical stuff. So I will go in another pessimistic slide, and sorry for that. I mean, PFAS in human blood and in on the humans is really bad. I mean, you may have eye diseases, cancer, liver toxicity. The increased DNA damage is something that may happen 100, 200 years. But the problems in many, many areas is you may have the women a problem with the birth of newborns, right? So the first indicator is that we have a hormonal disturbance. And this is because PFAS are trying to stick also to many, many paths in the nature, so they are not alone. So you may have also endocrine disruptors. They are working like endocrine disruptors. I mean, one of the first indications that we have in the science history because of the PFAS, we didn't know the name PFAS at that time, was 1990, 2000, as endocrine disruptors. So there were some behavioral changes, there are some metabolic changes in human history at that time in many, many areas with heavy industry. You may look in China, or you may look in western part of US as well. And this is something that European countries facing right now. Forever Pollution Project is a collaboration of newspapers and actually news journalists in European Union, across European Union, that they were trying to indicate in a map all the PFAS sources across European Union. So you may see the known contamination, so that means that we determine over there that we've seen PFAS, we know that there is PFAS, and we have the purple as a known PFAS user, which is very hard to find. It's only on, let's say, on the willing of the industry to declare that, at least at that time that Forever Pollution Project did that. And also we have the presumptive contamination at the manufacturer facility, which is also very hard because we don't have so many industries, let's say, in Europe. Or, this is one argument. The other argument is that we never trying to see PFAS in European Union. I mean, the regulation for drinking water is relatively new. I mean, it was about 2 years ago, Alexander, and I think we have, let's say, all the European countries, there is a deadline at the end of 2026 to implement this regulation. Okay, sorry, I mean early 26. So that means that if we are going outside and we are trying to find something over there, we may look or we may impress ourselves that there are numerous of or dozens of PFAS over there. And you may know that very well because of your master, that one of, and as we've seen that in the map before, one of the main, which is doesn't like a bridge, but the main bridge for PFAS is wastewater treatment plant, right? Because you may have seen that as a real target, the human exposure, but the real bridge, the connection for all those toxic substances is wastewater treatment plant. So don't take it wrong, because treatment plant means that they may treat nutrients, but actually they are not designed for treating micropollutants. I don't know if I'm wrong on that, Alexandros, but I think 8 or 9 to 10 treatment plants in Europe right now, they have this issue that they cannot treat micropollutants, right? So, and you know, a thought on that is that if you are trying to fight PFAS and you are trying to fight this, allow me to say this political comment, the capitalistic way of this, because this is the human consumption on commercial products, which is very difficult, right? It's very difficult, and or on landfill or on the waste or in the food, because you need very effective way to conserve your food, to bring food immediately to the market. So the bridge is wastewater treatment plant, or even it's a chance to fight or to stop this circulation. So this is why, and because of this map raise awareness to the European Union, this fight led to European Union to implement a new method, a new regulation for wastewater treatment plants. So those are the Greeks, but allow me to say that in English. So the new European regulation on December 2024 described that all the treatment plants, they have to deal and they have to treat the water in order to remove micropollutants. And more especially, the treatment plants that they are in cities more than, with the citizens with more than 100,050 citizens. You know, European regulation for the wastewater treatment plant is very complicated. It's a big one. They have major changes that, I mean, you have to change entirely the wastewater treatment plant. You have to, and the first thing is that you have to change entirely the mentality of a wastewater treatment plant operator. So this is the basic challenge. But let's talk about micropollutants. So with the new European regulation on wastewater treatment plant from the last December, we have the first indicator from written indicator from European Union that they declare that micropollutants are one of the challenges for the today's wastewater treatment plants, which is a big thing. Consider that we are almost 35 years before the previous regulation, and the regulation here describing micropollutants are as PFAS, as microplastics, as hormones, as other chemical substances and metals, toxic things. So, European Union will ask from every single wastewater treatment plant that they have the obligation to look after PFAS, to check and monitor PFAS or micropollutants, this is the better terminology, in the inlet and in the outlet, and give those data to the administration of each country and later on in European Union. And this is why they want to investigate, let's say, the risk points for each single country, but in parallel we have to dig more in order to understand the natural paths of why those PFAS are circulating. Because, okay, we may have the indication that if we throw away, a defective pan, or we are trying to seize a wildfire, or we may, let's say, give an impact of PFAS, but we don't know, or we may not know exactly the path of this recirculation of the PFAS again in the wastewater treatment plant. So you have to do tests in PFAS in the inlet, in the outlet, and even in the water reservoirs. If you remember the previous slides, is that before we are taking the water in the wastewater treatment plant, okay, one of the risk points as well are the water reservoirs, because of the agriculture, because of whatever, because of pesticides, and the chemical world is very complex. And the reason for that is that we may know the PFAS compounds as a substance, as a compound, but we cannot provoke what will be happen in the next 5 or 10 years. And this is the issue here. So the European Union, with this regulation, trying somehow to stop gradually this recirculation, at least for the drinking water. So for all the agglomerations with 10,000 citizens and more, all the European countries, they have to monitoring and send data for PFAS from their wastewater. So this is a very optimistic regulation. There are a lot of things to do about the frequency, about how you obtain those data, and how you can even make a national strategy about that. And one of the key things in order to stop this thing is, let's say, to implement or to apply some taxes or some penalties. I think this is the best word for that. So European Union here, in a very simple way, they decide in a way that the main player for PFAS or micropollutants compounds are pharmaceutical companies and cosmetic industries. So European Union, they found, let's say, 10 or 20 compounds that they are remain in the nature after the treatment of the wastewater, and they declare this that this comes from pharmaceutical industries and cosmetics. So those companies, those markets, they have to pay for 80% of quaternary treatment of wastewater treatment plants for the big cities. Big city in this means 150,000 citizens. A comment on that, again, a political comment from my side, is that it's very simple. Okay, it's like you have to apply a very optimistic regulation. You have to fight micropollutants, so you need money, and you go outside to the market. So you find the wealth markets, and you say, guys, you have to pay me. So okay, and somehow you exclude pesticides, plastics, petroleum, oils, all of those key players that they are very, very, responsible also for those micropollutants in many, many years, right? So this leads, and the parenthesis is going to close, this leads to a European fight against those markets, and this leads again that the fighting against PFAS and against micropollutants is very hard, because we are living in a very complex world, and the problem is that PFAS are very complex by themselves, so, and by our movements or by our decisions, we are making the world more complex. So I hope that there is bright light from my presentation, and the bright light is that because the technology is accelerating and we are inventing new methods to investigate what is happening outside, we may know total different things in the next decade. Imagine that 10 years ago, 20 years ago, we didn't know about that in such way we know nowadays. So, I hope that didn't get you bored. So, that's it, my presentation. Thank you very much. I appreciate all of you that you are here this cold evening in Creta and not in the sea or just walking outside. Thank you very much.